Hello to all, and this is the lecture number 6, third problem for the isoparametric quadrilateral element. So I am going to read the problem. For the isoparametric quadrilateral element shown in the figure, the Cartesian coordinates of point P are 6, 4. The loads are 10 kN and 12 kN are acting in x and y direction on the point P. Evaluate the nodal equivalent forces, and this is the diagram given, which having the 4 nodes and each node having the x and y coordinates, and we have to write the x and y coordinate in the first. So x1 which is equal to 2, x2 which is equal to 8, x3 which is equal to 6, x4 which is equal to 3, y1 which is equal to 1, y2 which is equal to 4, y3 which is equal to 6, y4 which is equal to 5. And point P, the Cartesian coordinates is 6, 4. The force acting on the x direction is 10 kN and the force acting on y direction is 12 kN. Then immediately we have to write the shape function of a 4-nodal quadrilateral isoparametric element. N1 which is equal to 1 by 4, 1 minus epsilon into 1 minus eta, and N2 which is equal to 1 by 4, 1 plus epsilon into 1 minus eta, and N3 which is equal to 1 by 4, 1 plus epsilon into 1 plus epsilon 1 plus eta, and N4 which is equal to 1 by 4, 1 minus epsilon into 1 plus eta. And then this is the Cartesian coordinates for the isoparametric quadrilateral 4-nodal element. X which is equal to n1 x1 plus n2 x2, n3 x3 plus n4 x4, y which is equal to n1 y1 plus n2 y2 plus n3 y3 plus n4 y4. Then the data which is given to solve the problem is start from the Cartesian coordinates, because the x coordinate is given, the y coordinate is given, the shape function we have to write the corresponding epsilon and eta values. Then this is for the x direction Cartesian coordinates, x which is equal to 1 by 4 n1 x plus n2 x2 plus n3 x3 plus n4 x4, and this is the corresponding values of n1 and x1 and n2 x2, n3 x3 and n4 x4. And once again, this equation is from the Cartesian coordinates of x. This is the value of x for the point P, and this is the shape function value and the corresponding x1, x2, x3, x4 value, and 1 minus epsilon 1 minus eta is the shape function, and this is the x1 value, and this is the shape function for the point 2 or node 2, and this is x2, and this is n3, and this is x3 and n4 x4. By simplifying this, we may get 9 epsilon minus eta minus 3 epsilon eta, which is equal to 5, and we have to follow similarly for y also. For y, the Cartesian coordinate of point P is 4, which is equal to 1 by 4, and this is for n1, and this is y1, and n2 y2, n3 y3 and n4 y4. By simplifying this, we may get the 4 epsilon plus 6 eta minus 2 epsilon eta, which is equal to 0, and this is the equation 1 and this is the equation 2. Then we have to substitute and find out the value of eta. Then we have to multiply the equation 1 by 2 and multiply the equation 2 by minus 3 in order to cancel the epsilon and eta. When we multiply the equation 1 by 2 means it may be a 18 epsilon minus 2 eta minus 6 epsilon eta, which is equal to 10. If we multiply the equation number 2 by minus 3 means minus 12 epsilon minus 18 eta plus 6 epsilon eta. So this will be automatically cancelled, and the next equation is the 6 epsilon minus 20 eta, which is equal to 10, and by this we need to calculate the eta value. The value of eta is 0.3 epsilon minus 0.5, and the third equation need to substitute in the first one. If we substitute the eta value in the equation 1 means 9 epsilon minus 0.3 epsilon minus 0.5 minus 3 epsilon into 0.3 epsilon. If you substitute the epsilon value in the equation 1 means we may get the epsilon value which is equal to 0.46. After getting the epsilon value, we need to substitute the epsilon into the eta value. Then we may get the eta value is minus 0.362, and then we need to substitute the epsilon and eta value in the corresponding shape function. If we substitute means we can get n1 which is equal to 0.183, n2 which is equal to 0.497, n3 which is equal to 0.232, n4 which is equal to 0.087 after substituting the epsilon and eta value. Then the problem is move on to the final stage. We need to find out the elemental force vector in x and y direction. So the general formula is F for the element which is equal to n transpose Fx Fy. We need to elaborate that F1x, F2x, F3x, F4x, n1, n2, n3, n4, Fx. F1y, F2y, F3y, F4y, n1, n2, n3, n4, Fy. If we need to multiply for find out the elemental force vector in x direction, we have to elaborate that F1x, F2x, F3x, F4x, n1, n2, n3, n4 multiplied by the Fx. The Fx is given as 10 and Fy is given as a 12, and we need to multiply all the shape function by 10 for the Fx, and we need to multiply by the shape function by 12 for the y-axis, and we get the f1x as 1.83, f2x is 4.97 and f3x is 2.32 and f4y is 0.86. For respectively f1y 2.20, f2y 5.96, f3y 2.79, f4y 1.03, and this is the procedure we need to find out the elemental force vector for the isoparametric 4-order quadrilateral element. Thank you.